We can also look at examples and sampling distributions for two population means when the standard deviations are unknown. Okay, so this will imply we'll be using the t-test. Again, we'll need independent samples. So there is two choices that we'll make. Do we pool the data? Do we not pool the data? Not pooling the data is the most common choice. Some people argue that we should never pool the data. But we'll need some assumptions before we can find the test statistic and perform the test. We'll need independent random samples. Sigma 1 and sigma 2 are both unknown. We do not assume that sigma 1 and sigma 2 are equal, although they could be. We do need the conditions for normalcy or approximate normalcy. So again, we need both sample sizes to be large, greater than or equal to 30, and the samples should come from populations that are normally distributed or approximately normally distributed. Okay, so again, we have the difference of the random variables for the averages, the difference of sample means. Okay, if we don't pool the data, that means the variances are assumed to be not equal. This is the most common case. Then we can use this test statistic. This will be the observed. Again, as all test statistics are, this is the expected. And then this will be our standard error. Now, if you do pool the data, the standard error becomes much more complicated, and the test statistic would then look the same way, observed minus expected over the standard error. Now we'll be using the t-test, so we're also going to have to worry about the degrees of freedom. Okay. We have choices for the degrees of freedom. The formulas that will result in different degrees of freedom because we have two choices, but the conclusions about our test will rarely be affected. So there's the simple and conservative way to choose your degrees of freedom, and if you do this, if you're doing it by hand, the degrees of freedom must be the smaller of the value n-1 or n-2, because it could be that the two samples are of different size. Now, the more accurate way to do it is the way that statistical software does, and they're using this formula. But it's much more complicated, so if you're doing it by hand, just take the smaller of n-1 and n-2. We'll be using the conservative, easier formulas. Now, the hypothesis of the test will still stay the same as we had before, that we'll be looking at the difference of mu1 and mu2. The null hypotheses will contain equality, while the alternative hypotheses will take the opposing viewpoint. Our calculator can perform the test for us, so you'll go to Stats, then Tests, and you'll be looking for the two-sample t-test. It will ask if you want to pool the data. Only pool the data if the population variances are unequal. If the variances are unknown, then do not pool the data. When in doubt, just don't pool the data. So the confidence interval, if the data is not pooled, again, point estimate minus error, our population parameter, and then point estimate plus the error. And the error, if it's not pooled, uses the simpler form. Remember, you're going to use the t of alpha over 2 here. Oops. We could put all of that together. This is the error and just form the big long inequality, and that might be, you might prefer to write it that way. Again, you're going to have to take care of the degrees of freedom, and remember, in this course we'll just be using the smaller of n1 minus 1 and n2 minus 2. Now, if you do decide to pool the data, again, the standard error is going to come in, but we're going to have to use that more complicated standard error if you're doing it by hand. If you do it this way and you're pooling the data, then we just have the simpler choice of n1 plus n2 minus 2. So you could also use a different statistical software, but again, for the simple calculations, it'll be n1 plus n2 minus 2. But we'll be using our calculator, so to do that, stats, tests, and then the 2 sample t interval.